Problem 16, Chapter 26, Take 2. So here we have a concave mirror with a radius of curvature of 60 centimeters. We want to calculate the image position and magnification of an object placed in front of the mirror at distances of 90 centimeters and 20 centimeters. We're also going to want to draw ray diagrams to obtain the image characteristics in each case. All right, so we'll begin. We know that our radius of curvature is 0.6 meters or 60 centimeters, so our focal length is half that, 0.3 meters. We know our object distance P is 0.9 meters, so we use the image equation 1 over P plus 1 over Q equals 1 over F. That's the same as saying 1 divided by 0.9 plus 1 over Q equals 1 over 0.3. 1 over Q equals 1 over 0.3 minus 1 over 0.9, and you can solve that as follows. You have 3 over 0.9 minus 1 over 0.9 to get a common denominator, and that's 1 over Q. Flip that and get Q equals 0.9 over 2, Q equals 0.45. So the magnification then equals minus 0.45 over 0.9. That's the image distance, that's the object distance, Q over P. And then equals minus 0.5. And if we look at our ray diagrams, that seems about right. The ray that goes in parallel to the line gets bounced out through the focus. The ray that goes through the center of curvature gets bounced out again back through the center of curvature. And the ray that goes to the focus gets bounced out parallel by the mirror. And they all intersect right here to create this much smaller arrow than the original arrow. It's about half the height of that, and that is what our numbers indicated, and it is also negative, which was also indicated by our numbers. So now, for part 2, we have a different situation. We have an object distance of 20 centimeters, 0.2 meters. We plug that in the image equation here. We rearrange the image equation. 1 over Q equals 1 over 0.3 minus 1 over 0.2. 1 over Q equals 2 over 0.6 minus 3 over 0.6, or minus 1 over 0.6. And so Q is I have 0.6 here, and it's really a negative 0.6 because it is on the opposite side of the mirror. And if we plug that into our magnification equation, we have minus a negative 0.6 divided by 0.2, and that is a magnification factor of a positive 3. So we know the image is upright. Well, let's draw our ray diagrams to the extent that we can. So I'm drawing 2 rays here because that's really all you need, but let's just be clever about things. So the ray that goes in parallel gets bounced out through the focus, and if you extend that line back in the dotted line, you get a line like this. The ray that would go through the center of curvature goes up to the mirror, and it gets bounced out back through the center of curvature. So it's just a perfectly straight line. And if you extend that back, they meet around here. And in this particular case, I haven't drawn this too terribly well because this is only about twice as big as that. And our magnification factor is actually about 3, but that is attributable entirely to my poor skills as a draftsman. But for the most part, it looks like it works.